In the modern age is fear of heights, fear of flying, even fear of germs. Can fear even be more insidious, such as fear of rejection, fear of social environments, experiencing fearful and traumatic memories in a haunting way with post-traumatic stress disorder, even fear of fear in panic disorder. Today I'm going to talk about how the brain encodes fear, how this can go awry in fear disorders and severe anxiety disorders, and how the new neuroscience of understanding emotion and fear can help us to inhibit and transcend fear in our daily lives. Fear lives in a part of the brain called the amygdala. The amygdala is about 2 inches inside of the ears. What's so fascinating about the amygdala and processing of fear is the same brain region is conserved across all mammals down to the lowest mice and most vertebrates. And the experience that we fear, the basic root of fear reflex that we have during these experiences of fear that we as humans have, is not so different than that of a mouse. And so it's allowed us as a field to advance our understanding of behavior, specifically the neuroscience of fear, more so than I would argue than almost any other neuroscience of behavior because of this conservation. Joe Ledoux made this classic figure showing how fear works at the most basic level. When we see an image that, even in its most cursory way, reminds us of a fearful stimulus, it activates the sensory representation in the eyes and then the first way station in the brain called the thalamus. The thalamus then sends this information to much higher brain cortical areas that lead to the conscious awareness of fear, or the conscious awareness more specifically of the visual image. But hundreds of milliseconds before we're consciously aware of it, the thalamus also, this midway station, sends a signal to this amygdala, which activates this whole hardwired reflex of fear survival responding. An experience that probably most of us have had is something like walking through a park, walking through the woods, enjoying a nice, pleasant day. And then all of a sudden there's a snake. Your heart's pounding. Your chest is up and down. You're breathing. You're sweating. You have to escape. And only after all that seemingly has already happened and time has slowed down do you realize it was merely a stick. What has happened is that your body has activated this fight or flight response before you can consciously be aware of what's happened. And that's going on every day in people with severe anxiety disorders and fear-related disorders. The cues of the world that activate fear are activating this basic primitive reflex before you can control it. This is what your brain looks like on fear. It's a functional magnetic resonance imaging of fearful versus neutral faces. And this has been, basic findings been replicated across the world. The amygdala is hyperactivated when a fearful stimulus has occurred. And what we find, and this is work by Amit Etkin at Stanford, is that across post-traumatic stress disorder, social anxiety disorders, specific phobias, the amygdala is hyperactivated, hypersensitive in these disorders. The root of fear of these disorders we can think of with the term a panic attack. And with a panic attack, people will have an experience where their heart is racing, their chest is pounding, they can't catch their breath, they're sweating, they have to get away, they feel like they're going to die. And panic attacks happen in all of these anxiety disorders. In panic disorder, it seems like the fear comes out of the blue, and in many ways, it's fear of fear itself. After the first panic attack, which is often at a time of high stress or depression or trauma, one will associate the experience of fear with the bodily reminders that occurred with the fear reaction. So the next time their stomach is upset or their heart is racing, they're afraid they're going to have another attack. It becomes a fear of the fear itself. With phobias, if you're afraid of a spider and a big spider lands on you, you're scared to death. We don't call it a panic attack, but it's actually the same symptoms. And similarly, with trauma and post-traumatic stress disorder, activations of the trauma memories activate the same set of symptoms. The reason this is particularly interesting, and again, these are the symptoms that we're talking about: chest breathing up and down, heart racing, stress hormones, the cortisol fight or flight, adrenaline response, stomach upset, heavy breathing, startle response, freezing, social avoidance. Decades of work by psychologists have identified that all of these symptoms are the sine qua non of panic symptoms. But separately, decades of work by neuroscientists have identified that this exact same set of symptoms in mice and men are the result of the hardwired fear reflex of the amygdala. Specifically, if you activate the amygdala chemically or electrically, that leads to downstream brain activation of multiple regions that lead to this exact same set of symptoms. Therefore, it doesn't have to be confusing anymore what these symptoms are. They're specifically the primitive fear reflex activated by the amygdala. And the question can then become, what's different between those who have fear disorders and those who don't? Why is the amygdala differentially activated in these people? What we focus on is post-traumatic stress disorder. We generally think about PTSD as a disorder related to combat and military. That's where the name first came from. But we now know that it occurs in times of terrorism, times of trauma, interpersonal violence, motor vehicle accidents, and other experiences of life or death situations. Why do some people following a severe trauma have high risk for PTSD, whereas others seem to be at low risk, or after any severe experience or trauma? One thing we know is that there seems to be a differential sensitivity. The amygdala comes to the time of the trauma with a different set of backgrounds, a different biology. Part of that's genetic. We think that 30 to 40% of the differential risk for those who have PTSD and other fear-related disorders is genetically mediated based on twin studies. We also know that a history of environmental stress and trauma can raise the stakes at the time of trauma exposure. We know that how the learning event occurs, how many traumas one has had, differentially sensitizes the amygdala and sensitizes the stress response. And we also know that what happens in the aftermath of trauma, the time at which this new fear memory goes from being a labile state to a more permanent state is very important. We heard earlier about Alzheimer's disease, and most of us think about learning and memory with relationship to explicit declarative new memories. But it's important to know that there's a parallel memory system, that's the emotional memory system, and we form new memories through this emotional memory system. And disorders of fear can be thought of as disorders of overlearning these fear memories. So one example of differential stress response or differential susceptibility is this example of a nature and nurture or gene by environment interaction. What Bender and Bradley and colleagues found was that increasing rates of child abuse is associated with increased PTSD symptoms following an adult trauma. What's so interesting was that a specific gene related to the stress response differentiates people who are at much more risk for child abuse-related adult PTSD versus those who seem to be resilient. It seems that even though they've had many, many trauma exposures, they're still relatively resilient. This stress-related gene differentially associates with amygdala activation as shown by Hariri and colleagues when they look at those same fearful faces. So what this tells us is that nature and nurture are combining to lead to differential sensitivity for risk after a traumatic experience. That genetic and other biological components are interacting with the severe trauma of the world around us to change our brain. And that then the brain, through this differential amygdala responding, leads to different sensitivity and exposure and responses to stress.